Hi, thank you so much for joining in on the webinar. This is Emily, who is from Byte Academy, and I'm just going to say a few words before we get our instructor, Leslie Cordero, started. This is the very first of our series called Learning Bytes by Byte Academy, and we're so glad to have such an international audience in our presence, and do have to tell you that we are located in New York and India. So, would love to meet you all soon. So, don't worry if I go through this initial information, as these slides will be available after the webinar. I just do want to say a few things about Byte and our awesome instructor before we begin.
Emily, could I ask you to share your desktop so that we can see your presentation? Share your screen up in the on the top of the control panel. You can click share show screen, and we'll get started.
Okay.
Do you have that orange arrow on top? If you expand the orange arrow, you'll see the sharing section, and simply click on show screen.
This is Leslie's screen.
Oh, okay. I'm sorry. Let me make Leslie then. Okay. Leslie, if you would go ahead and share your screen, and Emily can speak to your slides.
Okay, great.
Beautiful. And full screen, if you can put it in full screen. Excellent. Thank you. Go ahead.
Okay, great. Thanks for everyone's patience on this. So as we begin our Python versus R webinar, I will tell you a few words about Byte Academy. We are actually a leading coding school and the first to teach Python full stack bootcamp in a full-time format in New York City. We have a location in India, and we are known for our fintech program, in addition to programs in data science, quant algos, blockchain, and more. Our instructor leading the webinar, Leslie Cordero, is the lead data science instructor at Byte Academy. She has not only courses in boot camp format here, but also workshops available for those who just want to get their feet wet on data science related topics. She's also top rated, 5 stars across the board. If you don't believe me, check out some real student reviews. Now, I won't read all of these, as the slides will be available later, but just want to give you all a sense of who you're dealing with. So if you have questions during the webinar, use the questions section of the control panel. We'll try the best to answer these during the presentation, but many will be available afterwards. Also, at any time, check out our website, byteacademy.co, classes or social channels, to learn more. Now, I'm going to hand it over to Leslie, who will provide instruction for this webinar.
Okay, great. So to begin, we'll be using the Jupyter Notebook. So if you don't have that downloaded, do please do so. If not, a lot of students do like to just kind of head into the webinar or workshop without it, and you can just kind of listen along, and then since all of this will be available afterwards, you can actually just go through it again on your own if you would like. So yeah, but if you guys want to go ahead and download Jupyter, please do. That would be awesome. Yeah, so with that said, we'll get right into it. So you'll see this Jupyter Notebook right here, right, an intro to Python. So just to introduce you again to myself, I'm Leslie Cordero, and I'm a data scientist here at Byte Academy, as well as the data science instructor. So I teach many courses across data science in case you're interested in that. But besides that, we'll head right into it. So this is Python versus R, and first I'll begin with kind of explaining why I chose to do this specific topic and how it's relevant to data science. So data science is a subfield of computer science and statistics. So it's really where statistics and data and computer science meet. And really the focus of data science or data science projects is taking historical data and being able to extract any sort of information or trends from it. And that sort of information that you would extract computationally is information that can lead you to building machine learning systems, so recommendation systems, things like that, technologies that you use every day and don't even realize, such as trends on Facebook, any sort of Netflix recommendations, Amazon recommendations, things like that. That's all under the kind of realm of data science. So where Python and R fit in that is that they're actually the two most used languages within data science. So if you actually check, which are the leading kind of programming languages under data science, you'll definitely see R and Python, as well as maybe a couple of others here and there. But by all means, right? But by all means, R and Python are the most used within data science. So I'll head right into kind of explanations of R and Python separately, right? So R is an open source programming language. It is a statistical computing language that was really built by statisticians. So it is more kind of academic in nature, but as time kind of goes on, its use for industry has very much been ramped up. And a lot of that is due to the fact that it is open source. So R is definitely a language that's maturing over time. Now, this is similar to R, actually, Python is also open source. So a lot of modules are open source, and there is a very strong community there as well. But Python was built by programmers. So a lot of the kind of backend behind Python makes it so that programmers are more productive, right, and more efficient with whatever it is that they are working on, right? So this is the kind of perspectives in which R and Python were built from. So very different ones, but ultimately with similar goals of kind of making tasks in a computational manner. So with that said, we'll kind of go into some of the strengths between them. So R, right, has, as I mentioned, is open source and has a very active community. So there is plenty of support through Stack Overflow, and because R was really built by statisticians, its community focus is on data science or statistics. Versus Python, right, it is a more dynamic language. So because it's more dynamic and has kind of more use cases, the community isn't as large because a lot of the community is split across different applications, most of which aren't data science, because data science is just one portion of Python's community. So that's one advantage of R, is that all the support behind R is for data science or statistics. Right. So as far as picking it up for beginners, right, this is a common question I'm asked because a lot of people are interested in getting into data science and don't necessarily know where to begin. So if you're one of these people, then this is the perfect section for you. So R, right, has a very interesting syntax that is actually pretty hard to pick up for beginners. So usually I recommend personally that Python is a better beginner language. Obviously, sometimes different languages click with different people better, but generally speaking, I think Python is the better programming language for beginners. And again, that's because R does have kind of this like weird sort of quirky syntax, versus Python is very readable, and there's just so much documentation and tutorials for Python. And there are definitely resources out there for R, but I think the kind of community and resources behind that are backing Python for beginners is far better and more extensive. So again, if you're a beginner, I absolutely recommend kind of beginning with Python, and then once you learn one programming language, it's actually much easier to pick up a second one. So that's certainly what I recommend. So moving on, right? Another thing to know about these two languages is that each of them have their own package management system. So ours is called CRAN, and Python's is called pip. In Python, there's also Anaconda, but generally, right, we use pip more often. So these are the kind of large repositories that I mentioned that people contribute to. So they're all pretty much open source. And obviously, again, right, ours are pretty much all focused on data science statistics versus Python has libraries that aren't much related to data science. But these are the two package management systems, and these are where you will find modules or libraries that are that include tools that you can use for data science, whether that's in the realm of exploratory analysis, or machine learning, or natural language processing, whatever task it is that you want to do. Across both languages, there's usually a module or library that corresponds to it. So as far as modules and packages go, obviously, right, R has some that are stronger than Python, and Python has some that are stronger than R. And we'll go into what some of those differences are in a little bit. So the focus right here will be on, so this next focus will be on choosing, which is usually what people have the hardest time with. So I already mentioned about beginners, right? But if you're not a beginner and you're working on data science, a lot of people do have trouble kind of deciphering which one to go with. So as I mentioned right before, Python is more dynamic, and R is definitely built from the perspective of statisticians. So with that said, I have split this section into a few different criteria in which you can kind of get a feel from as to how to choose which language versus the other. So as I mentioned, right, previous programming experience is obviously going to be one of the most important factors, right? So if you have a prior programming experience, then Python or R is fine to learn, but I would still recommend Python. And I think, and again, this is just has to do again with the kind of readability of the language and how general purpose it is. It's a very flexible programming language, unlike R, which again is really very domain specific. So R, again, is not impossible to learn, but I think learning Python is absolutely much easier and more kind of user-friendly. It also has to do with educational background. So if you have a background in statistics and mathematics, right, R actually is actually a language that's very suitable for your background. As I mentioned several times, R was built by statisticians, and because of that, it was built with this specific education background in mind. So knowing statistics or having a general like intuition of mathematics really makes R make, I think, a lot more sense for you rather than people who don't really have much statistics background to kind of go along with. So, and because R is built for statisticians, it has a lot of, it has a very wide range of statistical techniques in which you can employ throughout your usage of R. So next we have career aspirations, right? So generally speaking, there are 3 roles under data science, and these roles are kind of flexible in what they include, but generally, right, we have data analysts, we have data engineers, and we have data scientists. So data analysts focus more on the analytical portion, as you would expect, and data engineers are really more building kind of the technology or infrastructure behind data science. So, and then lastly, we have data scientists who actually make a lot of decision making, and but definitely require a great deal of programming and statistical or mathematical background. So depending on the role that I think you are really aiming for is how important your choice of Python versus R will be. So for analysts, right, I think either Python or R is a great choice, with perhaps leaning towards R. So, and that's because again, R was built for statisticians in mind, and since the data analyst role does focus mostly on analytics, R just happens to be a very good choice for that. Now, for data scientists and data engineers, right, Python is probably one of the better choices just because it is general purpose. So as we'll kind of come to learn throughout this tutorial, we'll learn that Python is great for analysis or any data science sort of projects that aren't standalone. So what I mean by standalone is, they have to be, so standalone wouldn't be things that will be deployed on a website or some other sort of application. So if it's just standalone analysis, like you're taking a data set and getting summary statistics or something more statistical and it's not being sort of put into a product, R is great for that. But Python is super easy to use within an application. So as a data engineer or data scientist, generally speaking, you're probably going to be working with products. So because you're going to be working with products, Python is a fantastic language for that. And then next we have interest in deep learning. So deep learning is a very young field, but it's one that is definitely being developed more in Python. Python has different modules in deep learning such as Keras, Lasagna, Theano, TensorFlow. And all of these are very, very well developed by companies like Google or Facebook, which just has made Python a much more competitive language for this specific portion of data science. So, and again, the reason for this is because, just to review what deep learning is very briefly, deep learning is machine learning is a subfield of machine learning that really focuses on unstructured data. So because of the nature of unstructured data, oftentimes it'll be a computationally heavy task. Python was built from a perspective of computer science, so it was built with efficiency in mind more so than R. And because of that, Python is actually built in C and C++, and because of Python, which is essentially the C version of Python, it makes these deep learning modules work just so much more efficiently and therefore faster. So because of that, Python is definitely a leading competitor within deep learning. So now that I've given you an overview of the two languages and how they fit into data science and what their kind of similarities and differences are, we'll head into a little bit of code. So we won't be going through, most of this tutorial won't be, just you kind of watching me code. It'll just be, we'll be walking through some code and again, seeing how it fits within data science and how each language kind of outperforms the other. So in machine learning, we generally have training and test data. So a portion of the data will be used for training, and training is just the process by which your machine learning algorithms are built. And then we have test data to essentially verify our results. So generally speaking, right, you split the data into training and test data. And here I'm just going through how each of these tasks look in Python and R. So as you can see, some differences here. So the top cell is actually R, and then the bottom cell is Python. So as you can see right off the bat, things that are just different are like variable assignment, but also how CSVs are read and how things are split, right? So, but generally speaking, there's not much of a difference here. So they both use built-in functions to do the splitting. So while R does have more built-in functions such as like floor, sample, things like that, with Python you actually have to use built-in modules such as math or random.random, etc. So this kind of highlights one of the differences, which is that with Python, more often than not, you'll have to use a module for a lot of the data science tasks, unlike R, which actually just has it built in. This, depending on your specific task, might be an advantage or disadvantage. So again, this is because R was built in with statisticians in mind. So a lot of the things that were kind of afterthoughts for Python were automatically built into R. Right. So before if you looked at the code kind of closely, you saw that I imported a CSV file. So oftentimes your data will be in the form of a CSV file or some other text file maybe, but with Python you have to import pandas to then use it, versus R, again, has this built in automatically. And pandas is a very strong module that allows you to work with data frames, but in R, data frames are actually a built-in data structure. So it makes it, data frame usage is much easier to handle in R versus Python, where you have to import this extra library and kind of learn the specifics of another data collection that that pandas provide to it. In R, again, this is built in, so we don't have to consider other modules, and we don't have to depend necessarily on like an open source community with respect to data frames. Right. So both Python and R do have similar capabilities. So Python, in Python, this is the kind of top cell, right? We can use the head function to print out the first 5 rows. So here, this is what this specific data set is, and this data set is actually just data of different basketball players and their stats, their age, and other kind of background statistics. So in R, we have a very similar function. Both are actually literally called head. The only difference here is that because head is a function that's applied onto an outside library, we work with classes here, it becomes .head and then the parameter, rather than head and then the data frame followed by a second parameter. So again, not much of a difference here, but this just kind of shows you the very similar capabilities that both languages have. Cool. So next we have simple statistics. And again, this kind of emerging theme of Python having to utilize outside libraries versus R being able to just use built-in functions comes to play again. Right, so here we do nba.mean, which will get you what the average of each column is. Sorry. And then sapply here does the same exact thing, but uses a built-in function in Python. So both of these will return data frames with each of the different averages. So again, they do the same work, but how they do it is slightly different. And again, key here is really just that Python has to utilize outside libraries because it's not built with statisticians in mind. So again, this emerging theme is a very important one, and one to consider as you're kind of working within data science. Cool. So selecting specific columns, right? So after you load your data into a data frame, typically you want to be able to extract different columns from each, right? So in Python, it's an easier process because you can just actually directly index them. And in R, it's very similar, but you actually have the choice of either indexing them or using this $sign operator. Now, this is often confusing, and why I referred to R syntax is kind of quirky and strange, because things like this actually really confuse people, especially those who are just learning programming in general. So R has a lot of things that can be done in with different types of syntax, and from my experience teaching people, this can be a huge point of confusion. And this is just another reason why I generally recommend Python for data science kind of tasks. So before we kind of keep going on, I want to see if there are any questions actually to answer, and then if there are, I'll just kind of go through some of them. Yeah, so it says, I heard Keras and TensorFlow are also available in R. So I haven't worked with TensorFlow or Keras in R, but generally, um, so the short answer, right, is yes. However, because so TensorFlow is built by Google, and Google has far more people who are dedicated to Python. So the other TensorFlow and Keras have SDKs that are kind of better built with Python versus R. So while they do have implementations in R for both of these modules, the ones in Python are generally going to be better built or have more people contributing to it. So if there's, for example, a bug that is found, the response time will probably be quicker for the Python programming language than the R. And that's just really a matter of the fact that there are more Python developers out there, and especially, you know, pretty much at any company, but definitely at companies like Google. So as I mentioned before, R is very much an academic language, and because of that, there just aren't as many developers out there in industry that are developing in R. Sorry, but many people are developing in Python. So the next question we have here is, which one is, in my opinion, is better for automation? Right. So I think both absolutely are capable of automation, and I think this question really goes back to the fact of it depending on what your task is specifically. So if it's a standalone analysis, if it's something that you aren't going to be implementing into a product of some sort, perhaps you're just trying to get analytics for then making business decision, then R is just as strong, if not perhaps stronger, depending on what specific statistical tools you're using for that automation. Now, if you want this to be applied to a product, right? If you want this to be, excuse me, available in like real time on some application, Python is just built for that in a better way, and that's again because it is general purpose. So if you want to implement this into some sort of website, Python is definitely going to be the better language for that automation.
Oh wait, we just have one more.
Okay, so someone just asked me what the equivalent of RStudio is in Python. Good question. So generally, there are a few kind of IDEs available for Python. There's PyCharm, there's Canopy. You're actually kind of looking at one here, Jupyter Notebook. So personally, I think Jupyter Notebook is a great tool for either Python or R. And actually, one of the best parts of Jupyter Notebook is that I can switch between kernels. So if you look at my screen, right, you can go on kernel and then change kernel, and I have the option of both Python and R. So I can actually just use one tool for coding in both Python and R. So I definitely recommend the Jupyter Notebook if you're looking for something to kind of code on. Now, as I mentioned, right, there is Canopy and there is PyCharm. I generally don't use those two, and mostly it's because I do find there to be a lot of bugs here and there, which can be frustrating when you're, developing and you can't figure something out from your code, and then you realize it's because there's some sort of error with the software that you're using. Obviously, all software is going to have bugs here and there, but I generally find Jupyter Notebook to be kind of more usable in that regard. Yeah, so these are the questions that we have so far. And actually, I think I would like to go more into the Jupyter Notebook, right? So here, I did use the Jupyter Notebook, and some of the capabilities that it has are, so if I actually click on the screen, right, this is all Markdown, which is super useful for things like presentations. Then you can also, apply code here, and it'll run it just as you need it. Oops, I have it in the Python kernel. Sorry about that. But here, right, you can run code, and it'll run it for you as you want. And it has many options. You can download it as a notebook. You can also download as a Python file, as HTML, Markdown, LaTeX, or PDF. So Jupyter Notebooks are a super awesome tool, super great for those who are interested in data science, especially. So again, so just to wrap up, right, let's talk again about the sort of differences and strengths of each, right? So our programming, as I've mentioned and emphasized throughout this webinar, is really useful for statistics, right? So a lot of the statistical tools are built into R automatically, but even when you go into the huge ecosystem of CRAN, right, there are so many tools developed for statisticians, and it just makes the process of using things like or employing things like hypothesis testing or different probability techniques in a computational manner easier. And again, this is because most of the work that's being done in the open source community in R is specifically geared towards statistics. And again, as I mentioned before, Python is a more general purpose language, and because of that, the communities are more split, and there's just not as many tools and built in for Python. In R, right, we have matrices, we have vectors, and we have data frames that are built into R, versus in Python, we actually have to utilize other modules for completing these sort of tasks. So if we want to work with vectors and matrices, we have to use the module NumPy. Now, if we want to use data frames, we need to use pandas, rather. So again, these are just a few more kind of obstacles and that you have to kind of learn to deal with in Python versus in R. They're built in, and there's some of the fundamental data collection, so they're also typically things that you will see in an intro course, versus in Python, it's very much possible that you'll never see a data frame until you need to use it outside of the context of that class, right? So the learning curve, as I mentioned before, for Python is generally easier. So I definitely recommend it from the perspective of like an instructor and someone who also, once did have to learn both of these languages. Python is definitely, much more readable and has a kind of more general use for industry, I think. There are definitely companies out there who prefer using R, but Python, I think, is the more kind of common language used. And then we have visualizations. So visualizations, in case you're unfamiliar with the concept, right, is basically taking any data or kind of results, statistical results that you have come to conclude, and visualizing it in a way that's readable and sort of aesthetically pleasing to whatever users or whatever your audience is, rather. Right. So in R, this visualized data is often has many more tools, such as ggplot, ggvis, right? There's also Shiny and other ones. Python also has a lot of great modules, such as Seaborn or Matplotlib, Bokeh. But generally speaking, R does outperform Python. If you look at different visualizations of the same data in Python versus R, you'll actually see that not only are they more aesthetically pleasing, they're generally more detailed. They support doing visualizations in a more automated format better. But the downside here is that R does have Shiny, but R's support of deploying visualizations onto an application isn't as strong. And again, this kind of goes back to that same sort of theme where Python is much more general use. But otherwise, especially in standalone applications, right, R absolutely outperforms Python. Excuse me. I'm just going to take a drink real quick. Sorry.
Oh, yes.
And actually, we have a question, so we'll go into that right now. Oh, actually, perfect. So someone just asked about what the difference between speed is, and that's actually what my next section was, so perfect. Right, so as I mentioned, right, and I'm probably sounding like a broken record at this point, but art was developed for statisticians. So the code isn't actually necessarily the most efficient. Again, sorry. And that's just because it's built by people who don't come from a computer science background. Statisticians' focus is obviously on statistics, right? So they do that great, but computer science really focuses on like productivity and efficiency. So Python is generally experienced faster, and again, that's just because of who it was built within line and who was built it and who each language was built by. Sorry again. Right, so when to use each. So just to summarize everything that we've kind of reviewed, Python, when you need to integrate it into a web app or some other sort of application, it's a great tool to use just because it is much easier to work with. More people use it also. So in industry, it is much more common to use. And even if whoever you happen to be working with doesn't know Python, the learning curve is much easier. Now for R, right, again, its learning curve is pretty harsh. There aren't as many developers out there who actually know R. So I think in the context of like industry, generally R is less used. But again, that's changing just because people are realizing how important R's role can be in the process of statistical analysis, and it is becoming much more industry focused. The performance sort of portion of that is being worked on and being improved, every single day. Now, R, as I mentioned, is great for standalone computing. So it's also so exploratory work is especially important for R. And exploratory work just refers to when you're kind of given a data science project and you're not entirely sure like what direction to take. So I think R is especially great for kind of going through that process of deciding, oh, I should do this sort of statistical method on this data, or oh, I think this is like a good sort of path of exploration. So R is great for that. And Python is too, obviously. Pretty much anything you can do in either language, you can do with the other. It's just a matter of which each of them has their own strengths. And so for each strength that they have, I generally try to utilize it. As far as what my workflow generally looks like, my workflow is actually generally using both. And I use R for pretty much any standalone statistical analysis I need to do, and I use Python for production use. So a lot of people kind of treat this sort of question of Python versus R as only using one. But if you know both, I think that really does optimize your effectiveness as a data scientist or data engineer. And again, that's because if you're familiar with both languages, then you know which language outperforms the other in a specific task. So you can essentially end up kind of using your strength in both to decide whether you want to utilize Python or R for that specific task. So with that said, if a first good step for learning either of these languages are to obviously install the software if you don't already. For R, I definitely recommend downloading R and RStudio. For Python and pip are definitely steps. And then for both, I would use Jupyter Notebook. And if you want to look at some packages in R, right, I definitely recommend dplyr and plyr and data.table. And this is for easily manipulating data and packages. String R is to manipulate strings. And string manipulation is a super important part of data science because oftentimes they need to be cleaned or processed in some sort of way. Zoo is useful for time series, and time series is really just analysis and trend exploration of data that involves some sort of time component. ggvis, ggplot2 are very useful for visualization, and then caret is useful for machine learning. So I will see if there are any other questions, and then we can head into those. So someone asked, have I ever used Visual Studio or Django to program in Python? How do they compare to Jupyter? Okay, so Django, and so Django is actually just a web framework. So Jupyter and Django are really kind of separate things. So I wouldn't necessarily, they're not necessarily things to compare to because they just have, they're just used for different things. So Python, so the Ipython Notebook is really for, I think great for like presentations and using it as, you know, when you're just kind of working on your general workflow before you even really necessarily get into, you know, deploying things onto an application and whatnot. So Django is, as I mentioned, right, a web framework, and this is, if anything, you would compare Flask and Django, and Django is really more built with data science in mind. So generally, Django is used more often than Flask in the context of data science, and I think Flask, from what I understand, is more bare-bones. So yeah, so I wouldn't necessarily kind of compare the two. And then by Visual Studio, I am assuming you mean the kind of editor that they have, the built-in, I believe the built-in editor. I mean, Visual Studio is a fine tool to use. It is the one that I think comes from the Python programming language, but honestly, I haven't used it much, so I can't really speak to what its strengths and negatives are. But yeah, I think I did use it maybe my first semester of learning it in college. But beyond that, I think I eventually switched to either Jupyter Notebook or PyCharm. So again, just to kind of summarize that, Django and then Flask also are web frameworks. So they're not necessarily they're important parts because this data science, whatever kind of data science problems you work on might be deployed to a website, but as direct kind of comparisons, I don't know that there's really much overlap there. So the next question is, considering the libraries for backtesting finance strategies, which do you recommend better? So I think finance is actually maybe one of the exceptions where R can be used more often than Python, and that's because there are a lot of standalone tasks that are done within finance. So as far as backtesting and finance go, I think I would actually recommend R. And again, that's because a lot of the process is standalone. Now, and besides that, as far as deployment, I'm unfamiliar with what sort of technologies they end up using from what I gather, but yeah, I'm not too sure that Python is all that is as commonly used in the context of finance. So in the context of finance, I would generally recommend R. And I'm just checking to see if there are other questions. Yep. So someone asked, how would you go from a Jupyter notebook with visualizations to a production web application / dashboard? Right. So with Jupyter Notebook, so if you actually convert this to HTML, you'll see that the images are embedded. So excuse me. So Python, a lot of the visualizations are just deployed or just output as an image. So obviously, deploying images are fairly straightforward with web. But if you want to use modules like Bokeh or D3, which is in JavaScript, right? Those really make for very, very beautiful websites that can be deployed or visualizations that can be deployed into a website. So generally, I would recommend, if you're looking to have visualizations be incorporated into your website, I would look into either D3, either D3 or Bokeh. And both of them, again, are very web friendly. So if you're interested in that, that's absolutely where the direction I would go. And we're just looking to see if there are any questions. Really good questions, guys. Yeah, so someone asked about Mathematica. So they said that Jupyter reminds them of Mathematica. And they basically asked, are there things that are better in Python than Mathematica? So I'm personally not too familiar with Mathematica. And I don't know that there's much, personally haven't heard of much usage in industry, though I'm sure there are. But it's definitely not as common. As I mentioned before, right, Python and R are much more common languages used within industry, and they're definitely the ones that are more in demand. So Mathematica, while definitely has applications in data science, and that's because data science does have a lot of mathematical background needed, but Python and R are generally the two kind of most competitive languages. And we're just checking to see more questions. Yeah, and also, again, just to emphasize, right, all of this will be available on online afterwards. So if you want to come back to any material, you absolutely can. You can also, we'll also have these questions available to us so we can get back to them later on if we don't get to them right now. Additionally, right, you can also email us and we'll answer any questions as much as we can. But yeah, so it's about 12:50 right now, so we can actually get wrapping up. If you have any other questions, definitely put them, in the questions box. Otherwise, again, as we said, right, you can email us, check out our website, check out our data science courses if you're interested in. We actually have 2 courses that are in Python and R. So there's Intro to Python and Intro to R, in case you're familiar with, in case you're interested in either one of those. And each of them also focus specifically on data science. So if you're someone who's looking to get into data science or looking to switch from web development or some other computer science field into data science, those are definitely courses that are might be a good fit for you. But yeah, so I hope you enjoyed the Python versus R tutorial today. If you're interested in more, definitely check us out again. Yeah, and feel free to email me or Emily, and I'll switch it to Emily now.
Okay, great. So I'm just going to show you more details on how you can get in touch with us at Byte Academy. And again, if for some reason we missed your question, we will be answering questions after the webinar. I know that we have an hour time slot, and we hope that you can answer. Whoops, I'm just backtracking. Okay, we hope that you can find some answers by joining our community and or checking out some of Byte Academy's courses, full, part-time, and remote for all skill levels, data science, fintech, blockchain, Python, quant algos are all popular. We have a very strong community presence. More than 5,000 meetup members around the world. We do a lot of great workshops and events that are very informative and will help you learn a lot. Our Slack channel also, instructions on this slide here, which is available for download, is a great place to answer and ask questions on data science or any other topic falling underneath the technology umbrella. And just a slide on our contact information again, and we really hope to hear from you, and thank you so much for joining in today.
Well, Emily and Leslie, thank you so much for that information, and thank you for all that you put into today's event. I would also like to remind everyone that we have been recording today's session, and each of you will get a direct link to today's recorded playback soon after the session ends. So I did want to point that out. At this point, what I'm also going to do is quickly jump over into the into the Interactive Brokers website, because I do want you to be able to see. Let's go, here we have it. Notice now in the while I will be sending you a direct link, I also want you to see where you can access the information from Interactive Brokers. Notice if you type in webinar in our search field and simply follow the link here, you'll actually be brought to several different sections where you can view our previous recordings and then also go in to sign up for any of our upcoming recordings as well. Notice here when I click this link, it will actually take you to a page with our archive library, and today's session will be listed later on this afternoon underneath the APIs. Notice we've been building quite a library of APIs that will give programmers and those looking to program to or interact with global markets. IB does provide that unparalleled access to both global products as well as advanced trading tools. And here is where you're going to be able to find some additional information. We do have some courses on R, some on Python, as well as do be aware of the webinar notes that are listed over on the right-hand side. Today's event will also be posted here as soon as I get it compiled and uploaded to our servers. So I did want to point that out. But in this case now, looks like some additional questions have come in. I want to toss it back to Emily or Leslie if there are questions there at this point that you would like to return to or revisit.
There was one on our courses, which I responded to using the control panel to everyone. So people should be receiving it answered there. We're just trying to see.
We're looking at others.
I think we have most of these have been answered.
Yeah. Okay, all right. They've been coming in great, and thank you for keeping up with all of those questions. By the way, everyone, I do want to remind you that with today's recorded playback, I'll also be including a link to today's webinar notes, and all of the different URLs that Emily was showing you before will all be active and accessible through those webinar notes. So make sure you do watch your inbox later on this afternoon. Well, at this point, that is going to conclude our session for today. I want to thank everyone for your participation with us here this afternoon. Have a great day, everyone, and do remember to all trade smart. You can exit using the X in the upper right-hand corner of the screen. Thanks once again to our presenters, Emily Hunt and Leslie Cordero. What a great job you did today. Thanks so much for joining us, and we look forward to having you back for some additional sessions. So with that, we will conclude our event. You can all exit using the X in the upper right-hand corner of the screen. Have a great day, everyone, and thanks for joining us.
Thank you. Thank you.